Alright, welcome everyone to this third video on chapter 15, talking about chemical equilibrium. In this video, we're going to specifically talk about what happens to your equilibrium constant when you make modifications to your chemical reaction. Okay, meaning if you flip the reaction, if you multiply it by some number, if you add reactions together, right, what happens to that equilibrium constant? Okay, so right. As mentioning, right, that some change in your chemical reaction will change the expression for equilibrium constant K. So if we first think about multiplying reactions by some constant, right, let's say I have some original equilibria, right, N2 plus 3H2 goes into 2NH3, okay, right, that equilibrium constant for that reaction is just NH3 squared over N2 times H2 cubed, right? Assuming everything here is a gas, right? Right now, if I take that chemical reaction and I multiply by 2, right, I would get 2N2 plus 6H2 going to 4NH3. The equilibrium constant for that reaction, right, would be NH3 to the 4th divided by N2 squared divided by H2 to the 6th. Which just happens to be the same thing as NH3 squared over N to the 1 times H2 cubed, all squared, okay? Which in that parentheses, that thing is just the equilibrium constant of the original reaction, K1. And so K2, my new equilibrium constant, just equals the original equilibrium constant squared. Okay? So the general rule is if you multiply your chemical reaction by some coefficient, by some number, I have to raise my equilibrium constant to that same number, right? So I multiply my reaction by 3, I raise my equilibrium constant to 3, right? If I divide my equilibrium constant by 2, then I raise my power to 1 over 2, okay? Which is like taking the square root of your equilibrium constant. Okay. Now, right, let's talk about if I flip a reaction. So again, I start with my same reaction, same equilibrium constant, K1 is NH3 squared over N2 times H2 cubed. If I flip that reaction, right, I get that K2 is N2 times H2 cubed times NH3 squared, right, which is just the reciprocal of my original equilibrium constant, K1. Right, so we see here that K2 equals 1 divided by K1. Okay, so if you reverse a reaction, you take the reciprocal or the inverse, however you want to call it, of the equilibrium constant K. Right, so if I flip my reaction, I take 1 divided by my original equilibrium constant. Right, the picture shows here, right, turn it on its head. Right, is kind of the idea. Right, now what if I add two chemical reactions together? Right, let's consider, right, the equilibrium constant of this total reaction up above, right? And now let's look at two reactions down below, N2O2 plus going to NO3 plus NO, right? And then NO3 plus CO going to NO2 plus CO2, right? To the right are written the equilibrium constants for those things, right? If I add the reactions here, let me label these. So I'm going to call this reaction 1. Actually, we'll call that reaction 3. This is reaction 2, reaction 1, right? So if I add reaction 1 and 2 together, right, what you'll notice, right, if you add reaction 1 and 2 together, you'll get reaction 3, right? Because when you add these two things together, okay, these NO3s cancel, and then NO2 cancels, and you're left with NO2 plus CO going to NO plus CO2, okay? Right, so you get the original thing, right? And we see, right, if I add these two things together and if I multiply their equilibrium constants, okay, you'll see again that the NO3s cancel and the NO2s cancel when you multiply the equilibrium constants together, right? So I take K1 times K2, and I'm left then with K3, okay? So the general rule here is if you add two reactions together, you multiply those equilibrium constants together, okay? Right, so I add two reactions and multiply the equilibrium constant of reaction 1 with the equilibrium constant of reaction 2. Okay, so this kind of information is kind of summarized here in this table, and I also have summarized in this table what happens to your thermodynamic quantities like your enthalpy, right, which we talked about in Gen Chem 1, right, and then entropy and Gibbs free energy, which we'll talk about later in this semester, Gen Chem 2 here, right. So when I multiply coefficients by some constant, right, for things like enthalpy, I multiply the enthalpy by that same value. But for the equilibrium constant, I raise the equilibrium constant to that value, right? If I flip a reaction, right, reverse it, right? For enthalpy, it's reverse the sign, okay? But for equilibrium constant, I have to take the reciprocal, right? I have to do 1 divided by my original equilibrium constant. And then if I add 2 reactions together, right, for enthalpy, I add the 2 enthalpies, but for the equilibrium constant, I multiply the 2 equilibrium constants together.